Pre-calculus. This is Unit 11, parametric equations. So the first thing we're going to talk about is what is a parametric equation? Why do we need them? So typically we work with the XY coordinate plane, right? We've got X here and we've got Y, and we talk about the relationship that they have to one another. But now with parametric equations, we take two related values, X and Y, but now we write those as a function of a third variable, and we use the letter t to indicate that. And now t becomes the independent variable, and it is called the parameter. And it can be time to express how an object moves in the coordinate plane based on as time passes. So x and y can both be functions of time, so the horizontal and vertical movement of an object as time passes. Sometimes it can be an angle measure, just depends on the situation. So we want to talk about what a rectangular equation is because we're discussing what a parametric equation is. Well, a parametric equation, as I just indicated to you, we are going to have basically two equations, one for x as a function of t and one for y as a function of t. But we have to understand that when we refer to a rectangular equation, it is just the type of equation we're used to dealing with. It is an equation consisting of two variables that exist on the XY coordinate plane. So it's just basically all of the equations we've been dealing with, all of our functions, all of our graphing equations, etc., etc. Because, for example, if I was talking about the rectangular equation of a parabola, it would be, the parent would be y equals x squared. So now we're going to look at how we graph a parametric equation. So we're going to look at this first example here, and we're going to complete the table of values for our parametric equations. And we're going to sketch the graph and indicate the orientation. That means the movement, because remember, parametric equations show movement through your function as it relates to time. So we are going to fill out the table for time, or t, I should say, between -2 and 3. So -2, -1, 0, 1, 2, and 3. And then we are going to use our parametric equations here to find these values for x and y. So we're just using some substitution. That's all we're doing. So when t is -2, x is equal to -2 minus 3, so that's -5. And y, when t is squared, -2 is squared, that's 4. So I'm just going to fill in the table using the substitution into each of these for my x and y values. So what I end up with is I end up with these ordered pairs right here. Okay, so now we're going to graph these. So you can think of at t -2, that is a starting point or an initial point. So we're always going to talk about having an initial point because this shows movement through x and y as t passes. So I'm going to firstly plot all of these ordered pairs on my graph, my coordinate plane. So we've got this right here. So as you can see, this is a partial parabola. So hopefully you can see that. All right, so our initial point is -5, 4. Okay, and it is just right there. And as t gets closer to 3, we can see how our ordered pairs go along here. So we are going to use some arrows to indicate that movement. All right, so we're not going to verify these in our calculator. We're just going to graph these by hand. Find the rectangular equation of the graph. So now I'm going to write these equations as just one equation in the variables x and y, just like I normally would. So this is a partial parabola. Notice we don't have arrows going off in both directions, so it is limited by its domain and range because we only care about the parabola as it exists for t between -2 and 3. So when we create our rectangular equation, what we're going to do is we're going to look at x equals this and y equals this. So typically we write our rectangular equations as y equals something. So I am going to solve this equation for t so that I can substitute it into the y equation. So what that looks like is I'm just going to solve for t here, which means I add 3 to both sides. So now I'm going to replace this t with x plus 3. So that means y equals x plus 3 squared. So that is essentially my parent parabola moved over to the left 3, which that's exactly what it looks like, but it's restricted. It doesn't go off in infinity upwards. So I've got to write out a restricted domain. I'm restricted between -5 here and 0. So my domain is -5, 0. My range is also restricted because it doesn't continue up forever. So that's restricted between 0 and 9. So I'm just going to write that. So that is what my rectangular equation would look like.